Thank you, everyone, for coming to this session. And my name is Ray. I'm a developer advocate for the Google Cloud Platform. I cannot mention about what I do, but just to clarify a little bit more, right? I've been a Java developer for a very, very long time, probably almost 15 years now. And my job today is to bring some of the latest and greatest technology that Google and Google Cloud has to offer to the developers all over the world. But also, I love to get your feedback so that we can make all of our products and open source projects better. The best way to contact me is on Twitter @Saturnism. I also work on the Spring Cloud GCP project as well, like we mentioned in the keynote this morning. Please give it a try. Aside from technology, I love to travel, so I love to take photographs and stuff. So if you like to see some of the places I've been, you can actually go to Flickr. Now, today, I'm not going to talk of the theories of microservices. I'm not going to tell you whether you should be doing microservices or not. But what I will tell you is, if you do choose to use it to solve your problem, then here are some of the problems that you will also see and how you can manage those problems so you can actually run the full platform with all the capabilities you need. When you break down a monolith into microservices, or if you are starting out with a new application that's a microservices architecture, what you're going to see in the first thing is that all of a sudden now, rather than just having a single application you need to manage, then you need to run multiple instances of that app. Now you have multiple different services you have to manage, and every one of these services you have to run multiple instances as well. So all of a sudden you have this explosion of artifacts and runtime environments that you actually have to deploy and manage and keep secure, and all of those things that come with it. So there's a problem with deployment, and if you were to run this more efficiently, you wouldn't run every service in its own machine. What you would actually do is to try to get a cluster of machines, and you want to run different applications potentially on the same machines to better utilize the resource of that machine, like CPU and memory. As soon as you do that, you need some kind of resource isolation so that they don't step on each other's toes. You might want to be able to resolve any of the port conflicts as well, right? Imagine if you're running two Spring applications on the same machine. One of them has to run on port 8080, and another one has to run on 8081, and so on and so forth. And this becomes a management nightmare, potentially, if you do not have the right tooling. And fortunately, this has largely been solved by many different tools out there. For example, if you have platform as a service, it should be pretty easy to do. If you're running containerized workload, then you should look into Kubernetes. With Kubernetes, you can just say, here's my container that has everything I need to run it, and I need to run X number of instances, or we call replicas. And you can declare this deployment descriptor, and then just deploy it into the cluster, and Kubernetes will be able to manage all of these things for you behind the scenes, right? And the way that it works behind the scenes is something like this, right? With the container image that we create that has not just your application, but also the runtime environment. Which JDK version do you need? Which operating system level utilities do you need? All of these things will be containerized in this image. You push that image into a centralized repository. You send that configuration file into a Kubernetes master node. This is the control node that can control up to 5,000 machines within the same cluster. So the master will see this declaration of what you actually need to run, and it will actually, behind the scenes through the scheduler, figure out which of the machines can actually run this workload, and then schedule it to that, and then that will then download the container and then starting it. So there are very, very important concepts around this idea, right? So for example here, I may have example with a Spring Boot example. And if I go to my Kubernetes file, here I can actually see a few of these YAML file or these descriptors that I can use. So for example, if I want to see how I deploy my guestbook deployment, and this is like a very simple guestbook application, right? Within the context of Kubernetes, I would write a little descriptor that's of a deployment. And I would say I need to have 2 instances of my application running. And then here is the image I need to run, right? It's very, very easily done. And then I can also configure what URL to use for the health check and so on and so forth. Now, the beauty of this system is that once I have declared the deployment structure, and also once I have deployed what we call a service, which will, behind the scenes, create a load balancer for you, because that's necessary for your microservice to communicate with each other, right? Once I have deployed all of these things, what I can do is I can simply just do a kubectl apply. I can deploy all of these applications into my cluster very, very easily. So just like that, it's deploying everything. But I already have something deployed, so let me go just take a quick look. So this is my Kubernetes cluster. It has 4 nodes, so there are 4 machines behind the scenes. This is running on Google Cloud right now on GKE, Google Kubernetes Engine. Single click of a button, you get a whole cluster. But the beauty of Kubernetes is it can run in different environments, right? And here's my entire application, my front end, which has 2 versions, MySQL, a guestbook service, and the backend, and so on and so forth. And there's also definition on a ingress, so I can actually go and see this app, right? So I should have the URI here, yeah. So I should be able to come back here, and I should be able to go to this application. Ooh, interesting. That's an interesting color. Well, that's because I have 2 versions of this application running. I have guestbook 1 and 2. I got 2 versions. So right now, because I have 2 versions, this is going to be run robin between the 2 versions. Sometimes it's going to go to 1, and sometimes it's going to go to 2. Right? I can, of course, to make sure this works, hello, and that should save the data into the application. As you can see, that's all I know how to say, right? Hello, 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 right? This is not bad. This is all managed and controlled by Kubernetes. I can deploy a lot of microservices exactly the same way. Now, here are a few really, really important concepts to this system that usually people don't talk about. First of all, because Kubernetes can run anywhere, it provides an abstraction via a well-defined API, types or nouns, like a deployment, a service, and so on and so forth. These abstractions are abstracted away from the infrastructure itself, right? So that's why you can take your application and you can deploy it into any Kubernetes cluster, and they will probably function and behave exactly the same way. However, it also allows you to look at the entire cluster of machines, like up to 5,000 nodes, with a single view, right? You don't think about what machine do I need to use to run this app. You think about the cluster and how much CPU this entire cluster has. Then you decide on where to run your application. But the most important concept here is the separation between what we call a control plane versus a data plane, okay? That's very, very important. So the control plane is the Kubernetes master or the controllers behind the scenes that understands how to take this declaration and instantiating it into a real serving application, right? So the control plane merely take a declaration or a configuration file and then instantiates the actual serving path. So via the control plane, it will actually go into the infrastructure and create the actual running instances of your app and create the load balancers within the cluster and create, if you're on Google Cloud, the real network load balancers on Google Cloud, or if you're on another web services cloud, you'll create load balancers on that cloud as well, right? But your application doesn't care, and neither does your configuration. They are all the same, okay? So just keep that in mind. There's a separation between the control plane and the data plane that serves. So for example, if the Kubernetes master goes down, but that's okay because the data plane is still there, you still have the IP address, you still have the load balancer, and everything is still working, okay? You just lose a little control over the cluster until the master node comes back up, then it resynchronizes all the data, and then you can control the cluster again. That is just one aspect of managing your microservices. The second part of it, which people don't usually think about, is the network-to-network communication. As soon as you pull your application apart, they don't communicate within memory anymore. They actually have to go over the network somehow. And if you do go over the network, then you have a lot more issues. One thing is, well, first of all, what kind of data type, what kind of payload do I need to use to communicate with each other? I know a lot of people today default on JSON or use REST or JSON over REST, JSON over HTTP, right? But is that the right way and the best use of your bandwidth? Because as soon as you split all of your services apart, you're going to be using a lot more bandwidth than you would actually be using in the past, ever, right? So you need to have those payload as efficient as possible. At Google, we don't actually use a text-based payload. Everything at Google uses a binary protocol called gRPC, and we make 10 to the 10 RPC calls per second today in our data center. And that's only possible because we have very efficient payload. And gRPC is one of those open source projects that you can actually try. But there's a lot more problems, right? If everybody is trying to talk to each other via the network, then we are bounded by a lot more physics than we previously were. Speed of light or speed of your network, right? Or the bandwidth of your network. And the fact that the backend could actually go away, you need to be fault tolerant, you have to retry your applications, retry your calls, and you also need to understand what is actually happening in your system. And for that, you need ability to trace your application, you need full observability into the metrics, you need to know which service is running slower than the other, you need to find the root cause really, really quickly, and all of those things needs to be solved and tackled within a microservices architecture. And sometimes when I see customers doing microservices, all of these things comes after the fact. And what that means is they don't think about it until they run into an issue. But by that time, it's too late to provision any of these. Load balancing is also very interesting. When people talk about load balancing, there are really two different styles you have to keep remembering. And load balancing is depending on the workload, depending on the problem you're trying to solve. And I didn't realize this before, because for the longest time, when I think about load balancing, it's really just round robin, right? I don't know if anyone ever does anything different, but it's always round robin. But it really depends on the load and how you define the load, because not every request produces the same load. Some requests might produce a lot more CPU usages than another request. So you gotta figure out what that load means and how you actually load balance something. And then there's the idea of client-side load balancing versus a server-side load balancer, right? So the difference here is that, for me at the very least, is who actually has the control. If you trust your client, if you have full control over your client, then client-side load balancing might actually make sense because you eliminate extra hop to the server-side load balancer, right? And then if you need to update the load balancing rule to say who you need to talk to next, well then, if you have control of the clients, then you can make those changes to those rules. But if you don't have control to the clients directly, if it's a mobile application, if it's another organization, then you gotta really consider using a server-side load balancer or a proxy, okay? And today, there are many, many popular open source tools, especially in Java, to help you solve many of these issues. To use client-side load balancer, well, first of all, we need to know where all the backends are. What are their IP addresses in the port? And for that, there's Eureka, or some people use Console or Zool. There are a lot of other tools for you to register these services. And for client-side load balancer, we have Ribbon, and then we have Circuit Breaker, that's Hystrix, and then we have distributed tracing tools, and Prometheus, and Grafana, and the list kind of goes on. This is really good if you're on a single stack, and Spring Boot, they make all of these things very, very easy, right? But one thing you gotta keep in mind is that the more dependencies that we add, all of these things has to go into your client. So the more that we add to the client, then the bigger your application becomes. So in addition to just the business logic you're trying to solve, your application also has all of the logic to deal with these cross-cutting concerns that comes with the networking, and it comes with calling another service. Even though you didn't write that code, is still within your application that you have to keep it up to date and all that, right? But most importantly, all of these other things surrounding microservices to help you run it will actually add up really, really quickly. You need a way to store centralized configuration. You need a way to run your service registry. Maybe you run an API gateway in the front, and so on and so forth. And you don't just run one instance of any of these things. You run multiple instances of it. And now, all of a sudden, your microservice become a microservice. And then you have all of these infrastructure level components you have to manage as well, just to keep everything up and running. Again, this is very, very nicely done and very easy to do with Spring and Spring Boot. But this becomes a lot more challenging and a lot more difficult if you actually have multiple stacks or multiple frameworks or a polyglot environment where you don't just use Java. If you use something else, then what do you do next, right? Or if you have legacy application which you cannot really update or change, then you have to go back and figure out, okay, what are all the components I need to use to deal with these same cross-cutting concerns, right? And this is the challenge of many larger enterprises because they don't have just one single stack. They may have multiple different things that they have to consolidate to move into the microservices architecture environment. But at the end of the day, we really just want microservice A to talk to microservice B, no matter what application framework they're using, no matter what language they are speaking, right? As long as they can speak the protocol, that is good enough, right? It should be just as simple as making an HTTP request or a gRPC call or something like that. It should be very, very simple, and it should work across different environments with different frameworks and different languages, okay? So I'm just gonna go ahead and write some code, and you tell me what am I missing, okay? So I'm going to write 2 microservices right now. I'm doing this a little out of order, so I'm gonna see how this works, okay? I'm gonna write 2 microservices. One service is gonna be called work, okay? So that's the work service. How do you define work? Well, work for me is just going to a bunch of meaningless meetings. So I'm going to also write a meeting server, okay? So I'm going to write a meeting server really quickly, and then work is going to be calling meeting server, okay? And I know I'm at a Spring conference, I love Spring, but to show you what it might take, or the least amount of things that you need to do to get into a microservices environment, I'm going to use something that nobody here will probably ever want to use. Number 1, I'm using JDK 9, okay? Number 2, I'm going to be using a server that is the Sun HTTP server. Anyone use the Sun HTTP server for production? Yeah, there's like one person, yeah. So I'm going to do that. I'm going to try to do this as quickly as I can. Now, you might be saying, yes, I can do this with just a few annotations. I know, but this is really, really raw. You cannot be, you cannot go as more bare metal as this one, right? Unless if you write C, of course. Right, so I'm going to create a new HTTP server, and it takes the address. I'm going to be listening on port 8081. Okay, so here we have the server, and that will give me a reference to the server. And ultimately, I need to start it, right? And then I need to set an executor so I can actually listen to multiple threads as well to process multiple requests. And then I need to listen for an endpoint, so I'm going to say create a context. Oh, sorry. And I'm going to listen on the path meet, because that's what people do when they want to meet. They come to this URL. And that's going to give me an exchange object. And from here, I can actually do my meeting, right? I can actually perform the meeting, whatever I do. I don't know about you, but when I go to a meeting, this is what I do. Okay, and then of course you have this exception which we usually don't do anything about. All right. After I successfully slept in my meeting, I'm going to say, all right, I'm done. That was a success. I get to leave another day, and I'm going to say close. Right, and that's all it takes to write this very, very simple server that has absolutely nothing in it. So I'm going to run it. How many people think this would just work? Oh, wow, no one. Really? Nobody raised their hand? Oh, I feel really bad right now. Well, let's see. So it looks like it's working. So I'm going to say something like curl HTTP localhost me 8081. Now I'm a little scared, okay? No, I think that worked because if I time it, it's really just taking 300 milliseconds, right? Yep. So I slept for 250 milliseconds, and now it's taking 300. So that's fine. And then for work server, this is a little bit more complicated. I actually have to do actual work. So because of the time, I'm going to be a little lazy. This is what some people call backwards programming. Okay? Why is it backwards? Because I am typing it backwards. Oh, so we're done. Okay, so what this is actually doing, I don't know how many meetings you go to during the workday, but let's say I go to 4 meetings, right? I go to 4 meetings, so I have to use this, again, something you should probably never use. This is the HTTP client in incubation in JTK9. So I wish I'm using REST template here, but this is just a little bit more boilerplate, right? So I go to 4 meetings, and basically what I'm trying to see here is that the response is of the status code 200, right? So if the response was 200, that means I successfully went to the meeting, I slept through it, and I'm going to count it as one of the work item I have done today, all right? So that's pretty simple as well. So I'm going to run this as well. Let me see here, work server. Let me see if that will work. How many people think this will actually work? Oh, okay, the previous one didn't help. All right, so nobody, just so the people on the video understands, nobody think this will just work, but let's see here. I'm gonna say 8080 and work, and ideally this will go to, 4 meetings, and it took about more than a second because, 4 times 250 is like 1, so 1 second, so there we go. Not bad, not bad, okay? Now, without any addition to this, right, without any more additional thing, I mean, this is a microservice. This actually is, in fact, a microservice. If I actually build this service right now, Maven package, let me see if that's going, oh, wait, am I in the wrong place? Where am I? Oh yeah, I'm in the wrong place. GDK example, and my meeting server, and let me do the package here. If I run this package, by the way, this is going to package up everything into a jar. It's self-executable, and it's also building a container at this very moment. It's building a very small container to run my application because I'm going to deploy into Istio later. But if I look at the jar file in Target, this microservice is only about 3K, right? Now that's a very, very tiny service that just does something very simple, but there's no dependency whatsoever. I just want to show you that. There's really, really no dependency. If the backend goes down, well, what happens? If I kill the meeting server, if I just stop it, so if I stop the meeting server, what happens when you make that call again? So I'm going to say curl localhost 8080 work, right? It probably wouldn't work, right? It is general error because the downstream application is not there anymore. So without any error handling, without any retries, without any circuit breakers, this would just die, right? And all of the consumers will also receive this error just because one service went away. And that's why we need all of these other solutions to help you retry the request, to return a default value, and so on and so forth. But how do I actually just make this work, right? How do I actually just make this work? Given that's all the code I wrote, how do I just make it work so that we can take care of all of these cross-cutting concerns? And this is where the service mesh comes in, and this is what Istio is, okay? And to me, for a service mesh, you have to think about this as an environment or a platform in which when you deploy the application into, it will perform some kind of magic that will weave all of your requests in through the fabric of the mesh. And because it's weaved into the mesh, we can actually do very interesting things on your behalf when you make that microservice call. And it is designed to just connect and secure your application to application or service to service communication. It was an open source project that was created by Google, IBM, and Lyft together. And it is designed, again, to run in different environments. Okay? But today, it runs in Kubernetes right now. But tomorrow, there are people doing the work on running different environments in addition to Kubernetes. Okay? So what is a service mesh, and what is Istio? What does that actually do? Again, it's a platform where you can actually manage your service-to-service communication rules in a centralized way, including routing, canary rules, retry rules, circuit breaking rules, monitoring rules, tracing rules. You can define all of these things in a service mesh through a control plane. That is the important part. So rather than building those application logic into your application or including a library into your application, once you deploy the app into the mesh, we can control all of these cross-cutting concerns directly through a well-defined declaration. So rather than coding or defining these within your code, you just write another YAML file, another declaration, to declare the type of circuit breaking rules that you need for your service. And you apply it, and then behind the scenes, it gets instantiated into the serving path. So now every application gets the same benefits. This is absolutely really, really cool and very amazing. So what that means is that rather than running all of these client-side jars and client-side logic that you include in the app, they can kind of go away. Rather than having to run like a gateway or a registry and all that, that could also potentially go away if you're in Kubernetes, because Kubernetes has a service registry. Kubernetes has ingress, which can act like a gateway, and Kubernetes has configuration, so that can also go away. You might still need some other things like Grafana, Prometheus, and Zipkin, but we can later see how Service Mesh can help you in this case. So all of the things that you put on the client side, they have to go somewhere. They don't just disappear, right? You can't not just take some logic away and say, well, they're gone. No, you have to move that code to somewhere else, and that somewhere else will be a dedicated proxy that will run alongside of your microservice, okay? So rather than including all of these cross-cutting libraries that you actually need for every one of your services, we just move that logic into a dedicated proxy. This is a very small process, okay? Now, you might be saying, well, hold on a second, right? So this proxy can do a lot of things. This proxy can do all of these things, right? This server proxy can do all of these things for your microservice. Then you might be asking, well, that sounds a lot like the 1990s when we have something called the ESB, right? How many people here have used ESBs before? Yeah, like half of the room who lived through that era. I'm sorry. Yeah, but I mean, yeah, it's very similar in concept that we all want to try to deal with these problems in a cross-cutting way. The difference here is that in the past, an ESB is deployed in a centralized location with a central server, and every request has to go through this central server or a centralized ESB, and it creates a bottleneck. And every request is actually going to go through the network and then go through the network again, so you have two hops. In terms of a service mesh, the proxy is deployed one proxy instance per microservice application instance. Okay? So if you have 20 instances of a microservice, you get 20 proxy instances for your microservice, right? Because every proxy is associated with just one microservice. Okay? And this proxy, of course, is made to be very efficient and small. I mean, we don't take away 80 megabytes worth of jar files and replace it with a 200 megabytes proxy. That wouldn't make a lot of sense, right? You don't want to go bigger in that case. Smaller is better, right? So in this case, we're using Envoy proxy. This is the proxy written by Lyft. It's been battle tested in production. They actually use Envoy today in Lyft, right? So this is something that they have been optimizing for a while. And this is the proxy that you get to do these cross-cutting concern work, okay? And this proxy can do a lot more than just what we talked about earlier, okay? The control plane itself is called Istio Pilot. So basically what we're going to do is to write a service-to-service communication rule in a YAML file. We can push it to Kubernetes, and then the Istio Pilot will see this declaration, and what it's going to do is to parse this configuration and then go to all of the proxies and configure those things individually. Okay, so this provides you this centralized control plane. Once the proxy is configured, that is your data plane. That is how your application is going to serve. If the Istio Pilot goes away, well, that's okay, because the proxies already have all the information. It just doesn't have the latest information, but it can still serve the application. And again, we every microservice instance gets a proxy. So what that means is that behind the scenes, we will actually put in an IP table rule that will intercept every connection. Okay, not just every request, actually intercept every connection. So by default, your microservice cannot make any connection to anywhere because it will always have to go through the proxy. And proxy is going to get this one connection that you say, I need to talk to microservices B, okay? Well, and then proxy is going to say, okay, I see this request. Can you actually make that call? And if you can, it's going to forward the call to the target instance. So proxy will actually have client-side load balancer in this case. So the proxy knows all the destinations, and it will pick one of them to go to, and then connect to the destination service. But on the way in, we also intercept that connection as well. And so we examine the request to see, does microservice A, can A actually call me? And if you can, well, that's great. We'll keep on forwarding the request to the actual instance, okay? And the response goes back the same route. And that is exactly how the service mesh works. This is, Matt Rabel once said, this is like the aspect-oriented programming for your microservices, right? Rather than doing AOP in Java, this is like AOP for your service, for any language that you have. Now we can ask really, really interesting things. So for example, if we need to know latency between two services, how do we get that? Well, that's easy, because the proxy knows when you made the request, and the proxy knows when the response came back, and now we have metrics. We know the latency. If we need to know, well, who's calling what? And that's also very easy, because all of the connections is intercepted in this case, and the proxy knows who you are talking to, right? All of this data can be stored and analyzed later, right? And the best part of it is that, I don't know if anyone here have ever tried to attempt to do the unfeasible thing, the impossible thing, which is to use SSL certificate in Java. Anyone? Yeah? Let alone doing that, try to use mutual TLS and also rotating certificates frequently. That's the code that you actually have to write a lot for. And imagine doing that, not just in Java, but with all of the other platforms, other languages you have. That's a lot of work. That kind of work is now offloaded into Istio, the service mesh as well. So in Istio, there's something called Istio auth. What I can actually do is to provision a certificate authority and then issue a certificate for all of your microservices, right, for different privileges and permissions, right, or identifying itself. And then these proxies can actually establish mutual TS connections between all of your microservice connections over a trustless network. And you don't need to actually write any code to do that. You just have to configure your application to say, you need auth, well, then you have it, right? So this is all being done transparently. Now, some of you might ask, well, isn't there still a network connection here between the service and the proxy? Well, there definitely is, but because the proxy runs alongside of your microservice, they are always running on the same machine. What that means is that this connection is actually local. It's a local host connection that's usually highly optimized within your Linux environment anyways. So this is not a network hop. It's just a local connection to your to a local port. And then the proxy then can establish a mutual TLS connection over the network to the target and keep on forwarding the data. And that's it, okay? All of the data that we collect, or Istio can collect, by default, they can be forwarded to things like Prometheus, which then can be visualized by Grafana. The trace information can be collected by Zipkin, right? All of these things you might be familiar with, you might actually be using today. You can still continue to use that. But remember how Kubernetes has a set of nouns and types that abstracts away the underlying infrastructure? In this case, the proxy, Istio, they also abstract away these underlying platform services that you need to operate and monitor your application. So, through this abstraction, if you ever want to use a managed service for some of these things, well, you can. You just replace the plugins, and now You can be running a Stackdriver trace on Google Cloud. You can be monitoring the metrics on Stackdriver as well, and so on and so forth. That's because this connection, the data store itself, is abstracted away from your platform. So in Kubernetes, you can deploy the same app across multiple environments. In Istio, you can deploy the same rules across the different environments, and you can still collect and monitor your application in these different environments as well. So it's really, really nice. Okay. And ultimately, again, the mutual TLS stuff is super awesome. What happens behind the scenes is that every one of your service gets a service account, and based on the service account, it assigns a certificate that identifies who the caller is. Same thing with the receiver. They establish mutual TLS, and then you can actually write rules to block access to certain URL endpoints, and so on and so forth. Okay. So let me see, just to show you a few more demos, right? So here I've written 2 services, right? Very, very simple. 30K, in this case, no Spring, unfortunately, but it's very, very bare metal, right? There's one thing you absolutely have to do to use Istio, the system, okay? And that is you actually have to propagate the headers yourself. You actually have to propagate the trace header. What Istio will give you is to say, oh, if you don't have a trace header for distributed tracing, Istio will generate one for you. But it is your responsibility to pass it on. Okay? So in this case, I'm just going to pass on the trace header here by myself. Let me see if I can do this really very quickly. So I have a list of trace headers. They're using the standard XP3 headers. So if you're actually using Spring, you should be using Spring's Cloud Sleuth, especially the second version, Spring Cloud Sleuth 2. They use XP3 headers behind the scenes out of the box. So all of these things will just work out of the box with Spring and Spring Sleuth. You do need it because you need to propagate the headers, okay? So with the headers, let me see if I can write this very quickly. So I have a list of headers. I need to map it to something. So I'm going to map it to a header entry in this case. And I'm going to get the name of this header entry. So there we go. So here's the header name. And I need to get the value, so I think that's in the exchange. I'm going to get the request headers. I'm going to get the first value of the header, whatever that I need to look. Again, the XP3 headers, right? And then I need to actually filter out a few things because some of these headers could be empty. So I'm going to say, well, I'm going to only have the headers where the value is not null, okay? And once I have all the headers, then I need to propagate it to my actual request. So for each of the header I have, I'm going to say builder.setHeader, and then I'm going to say header.name and header.value, okay? Again, if you're using Spring, you could be using Spring Cloud Sleuth to propagate the header for you. That would just be seamless. I just wanted to show you the bare bones here, okay? And that should still work, I hope. I'm hoping. So let's see it. I'm going to say work without, oh yeah. I need to stop it first. Let me just make sure that works before I continue. So here's my work server. And here's my meeting server. I just want to make sure everything works before I push everything to the cloud, okay? Whew, scary things. Okay, still works, that's good. So I have done the Maven package here for my meeting server, so that's going to, package the jar, putting the Docker container for me. And then here I'm going to do the work server as well. I'm going to say Maven package here too. So again, it's going to package up the jar, build my Docker container for me. Again, this is all live. There's no cheating here. If it doesn't work, it doesn't work. Okay, so I'm hoping everything works. So it also pushed the container into the registry. And then I have this little Kubernetes file that I can actually see. Kubernetes latest. Right, so I have these deployments. What I can do is I can just go ahead and deploy everything. Okay, so I'm just going to go ahead and deploy everything here. So it's going to deploy the work server and the meeting server. It's going to create the load balancers. Now, when this is happening, there are 2 ways for us to actually inject these proxy components. Okay? One way, if I open up the meeting deployment, for example, again, this is a very straightforward Kubernetes file. But here we have the image that we need to run, which is the one I just created, that I just registered. If I need to inject the proxy, there are 2 ways to do it. One is with the Istio command line. I can do something called Istio CTL, kube inject, okay? And then give it the file, which is meeting deployment latest. And what this will do is to analyze this YAML file and then figure out what it is you're trying to run, but also add additional things to it. So in addition to the application itself, which is here, this command line will also add the proxy, which will be running as a sidecar next to your application within the pod, within Kubernetes construct. And it will also set up this, what we call the Innate Container, and this container is the one that sets up the IP table rules that will intercept everything, okay? If you don't want to do this manually, you can do what I have just done, which is by using what we call the Sidecar Injector within Kubernetes. What that means is you can deploy a regular Kubernetes file, and behind the scenes, there are these webhooks that's going to kick in and automatically add these proxy configuration into your deployment. So even though I didn't have a proxy, but as you can see here, it's actually running 2 containers here, because one of them is proxy, because this is injected automatically. Now, if I actually want to try this out, I can go to the ingress, and I can make a call, okay? And this is just live, and code work. How many people think this will actually work? Wow. All right, there are a few more hands. Thank you, but we'll see. Very, very nervous. Okay, it actually does work, which is great. Awesome, right? So as you can see, this is a very minimal application, but we're getting all of the benefits from the service mesh. Number one, if I want to see, let's see, if I want to see any metrics, I just made a few calls, right? I just made 2 calls here, 2 calls. If I want to see any metrics, I didn't have any additional components in my app. I can actually go to Grafana right now, and I can go to port 3000. I can see a Grafana dashboard in this case, okay? And if I go into the dashboard, I will actually see my QPS and my success rate. This is not bad. And to show you that this is actually between service calls, I can here choose, I want to see the communication between the work server, right? And the destination will be, I can choose that. Between that and the meeting server, right? And I can see the QPS between these 2. Again, without anything I have done extra. If I want to do more, I can. So for example, I remember the headers I just passed. Without having Zipkin clients directly in my code, all of the codes are actually being traced as well because we have the header propagation that I added myself, right? So if I go to my system, go to Zipkin, if I go find traces, I should be able to see one of these things. That's not it, but I didn't see the ones, but let's suppose this is the one. You can actually see all the traces directly in Zipkin as well. Okay, out of the box directly from Istio, because we capture the headers and then we propagate the data directly to Zipkin, right? Very, very cool. In addition to that, we also have something called a service graph. So let me see if I can get that one. Yep. So with a service graph, what we can actually do is to use the data that we collected and actually draw the actual service-to-service code tree so that you have a full visibility into what that system looks like. So here we can very clearly see there is the unknown, which is me, right? I'm from external sources. It code into the ingress, which is our front end, our HTTP load balancer, and that forward the code to work server. Again, the proxy knows who's calling what, and that made a code to meeting server, right? That all just works out of the box. But things get even more interesting if we actually start to define the rules. Okay, so if I go to my Istio by example directory, let me just make sure I have it, and then if I go to the JTK example, if I go to Istio rules, now we can define rules with our services. Okay, rules takes many different forms. There are many, many different things we can do. We can have a routing rule. We can have destination rule. Basically, what these rules are is which service do you need to apply the rule to? Does it apply to certain type of caller? Which request do you need to match based on the HTTP header or the request URI? And then you decide what you want to do. Do you want to route it to another service? Do you want to route it to a different version? What do you want to do, right? Do you want to play Chaos Monkey and just return 503 errors? Do you want to rewrite URLs, right? So we can just write these rules, and all we need to do is apply it. So for example, if you want to be fun, I like to be fun, you can be that one person who add this one rule, right? So what this rule will do is to abort 100% of the calls, okay, and return a 503, okay. And again, you can reduce this to 10%, 1%. This is a really, really good way to test the resiliency of your application. All I need to do to apply this rule is by using, in this case, I can use Kubernetes. I can say kubectl apply 503. So I'm going to return 503 for any of the call made to the meeting server. And now if I do a curl to work, I can very clearly see that I went to 0 meetings because they are now all returning 503s. I can, of course, edit this rule as well, right? So I can say rather than 10%, let me go 100%, let me go 10%. All I need to do to apply, remember the control plane versus data plane? Control plane configured the data plane. So now, if I make this call again, there will be 10% chance of getting a 503, which is really, really neat. You don't have to change your code for this. And this is really nice if you have multiple versions of your application and you need to do a canary release. So for example, if I go back to my Spring Boot application, right, and if I get to the Istio rules here, so where's my app? 1 second. Let me close out. Almost down here. Yeah. So this is my application. Right now, this app is also deployed in Kubernetes in the same Istio environment, and you can see it round-robining between different versions. So I can go ahead and apply a rule, for example here, route to v1. Okay, so what this rule is going to say is route everything to version 1 of my app. Okay, and I can just go ahead and apply it to v1, and that's it. The Istio pilot received this request. It goes out and configures all of the proxies. And when everybody catches up, now every call is going to v1. And if I want to say, you know what, let me route 20% of my application to v2, I can definitely do that as well. So I just need to update the rule to say, rather than 100% to v1, I'm going to write a rule that split the traffic between v1 and v2. Again, this is a really, really good way for you to canary a new release. If you're not so confident of how this is going to work out for you in a deployment, you can just deploy it and you can ramp up the traffic. So if I apply this rule, now I have 20% chance of getting a v2. Okay? So it will be 20% chance, so we may not see it if I keep on refreshing it. You will eventually see it. We can also route based on other things. So remember, we are able to intercept L7 traffic. So what that means is we can also introspect the headers or the URI. So we can also route based on, say, user agent. So if you have a service that needs to be behaving differently between, say, a mobile device versus a web browser, you want to send them to different versions, you can test that out. You can use the user agent and figure out which destination to send to. Okay? And there's many, many more things you can try. The most important one, the one last thing I just want to say is about circuit breakers. Typically, when we think about circuit breaking, we think about error detection. We think about outlier detection. If you have 10 backends, if one of them is down, what do? In the regular circuit breakers that you are familiar with, you'll mark that instance as bad, and then you retry it later, right? But if you think about the real circuit breaker in this house, in this auditorium, if a light bulb goes down, right, does the circuit breaker in this building say, let me stop delivering the power to the light bulb and let me retry that later? It actually doesn't do that. The circuit breaker in this building, its job is to protect the components here from getting too much power, right, or from drawing too much power as well. So we do have a circuit breaker like that within Istio as well. And what this is really good at is to protect your services from DDoSing or from oversurging. And so you can actually say like how many connection max can you actually handle in your services, and we'll block the rest of them if there's somebody who's trying to overload your service. You should always know how much load your service can actually handle, right? So these are just a few things that Istio can do, but the most important thing is all of those connections I just made, well, if you turn Istio Alt on, They will be secured by mutual TLS, and your application will just work. That is actually really, really nice. So again, for Istio, it allows you to gain visibility inside your application, allows you to control your traffic and service-to-service communication. It is in 0.7 or 0.8 right now, so it is not ready for production. Okay, just want to make that clear. It is not production ready. The proxy is, but the entire control plane is not. It's because they are changing, they're trying to figure out the best way for you to configure it. So they are targeting a 1.0 release this year. So the reason why I'm here is that this is the perfect time to start using, to learn about the concept, and to try it out. And please, please, join the groups, join the GitHub project, and send us the feedback that you have. And go to istio.io. It's got a community link where you can actually join the community meeting with the engineers who are working on the system so that you can get your voices heard, right? And if you have any other requests and questions on how to get it, you need to do to get it work, please let me know and join the group as well, okay? And lastly, I do have this talk recorded with the code, the samples, and a collab if you want to try it on my website. So I know my time is up, so thank you very much for your time. I really, really appreciate it. I'll be at the booth on Google, so come by and say hi. Thank you.